Welcome back, everyone. Today, in this explainer, we're diving into the hidden science and engineering behind something you probably have stuffed into a kitchen drawer right now, the modern reusable shopping bag. It seems like a pretty simple everyday object, right? But as we unpack the material science and manufacturing processes today, you're going to see just how fascinating this material really is.
Here's a quick look at our roadmap. We're going to cover the reusable revolution, decoding GSM fabric weights, how Spunbond is actually made, custom printing and finishing, and finally, how to find the right supplier. Let's get into it.
Section 1. The Reusable Revolution.
So we're in the middle of this massive global shift away from single-use plastics, which brings up a huge logistical challenge. Think about the billions, actually some estimates say over 1 trillion plastic bags used globally every single year. So what's replacing them? What material actually has the perfect characteristics to take on that massive global demand without breaking the bank?
Well, the answer is polypropylene spunbond fabric, or just PP Spunbond for short. This is a highly durable, lightweight, and extremely cost-effective non-woven material. It has literally become the hero of the reusable bag industry because it perfectly balances 3 competing needs. It's incredibly strong, it's super lightweight, and it is highly cost-effective to produce at a massive scale.
What's really interesting is how this stacks up against alternatives like paper or cotton. Polypropylene Spunbond offers some major game-changing benefits. First, it's as lightweight as a feather but remains incredibly durable. Second, it has this fantastic tensile and tear strength, so it can handle heavy loads. Third, it's completely moisture and water resistant, unlike a paper bag that completely disintegrates in the rain. On top of all that, it takes custom printing beautifully for branding, and it's 100% recyclable. It's basically a triple threat of durability, lightweight performance, and cost efficiency.
Section 2. Decoding GSM fabric weights.
Now, if you want to understand the structural integrity of these bags, you've got to speak the manufacturer's language. That means understanding GSM, which stands for grams per square meter. It's the absolute crucial metric that dictates a bag's strength, durability, and cost. Think of it like this. If you go to a trade show and someone hands you a flimsy promotional bag, you're probably holding a 20 to 30 GSM fabric. It's perfectly fine for some lightweight brochures. But if you're lugging heavy canned groceries home in the pouring rain, you need a heavy-duty workhorse, something right around the 70 to 90 GSM range. Choosing the wrong GSM means you're either overpaying for thickness you don't need, or you're giving your customers a bag that's going to rip on the way to the car.
So you're probably wondering, what's the industry standard? Well, 40 to 60 GSM is the absolute sweet spot. For your standard retail shopping bags, think clothing boutiques or your typical supermarket checkout bags, this specific range provides the perfect equilibrium. It holds a decent amount of weight while keeping production costs totally manageable, meaning retailers don't have to charge an arm and a leg just for the bag itself.
Section 3. How Spunbond is made. Let's look behind the scenes.
Remember how I mentioned it's a non-woven material? That begs a pretty fascinating question. How exactly do you get a fabric this strong without weaving a single thread together? Traditional weaving takes a lot of time on looms, which drives up the cost. The non-woven process is where the true engineering magic happens.
It all comes down to 4 really clever steps. Step 1 is extrusion. Raw polypropylene resin is melted down at extreme temperatures and blasted through tiny spinnerets, creating thousands of continuous filaments. Step 2 is stretching. These fine threads are pulled super tight to massively boost their core strength. Step 3 is web formation, where these filaments are just laid out randomly onto a moving conveyor belt. And finally, Step 4, thermal bonding. This whole web passes through heated calendar rollers. The heat and pressure permanently fuse the fibers together into a solid, breathable fabric. So there's no knitting, no weaving, just pure, brilliant thermal engineering.
Section 4. Custom printing and finishing. We've built the structure of the bag, but now let's talk aesthetics. Because a reusable bag is essentially a walking billboard for a brand. Choosing the right printing technique for your specific volume is key here. Screen printing is fantastic because you get these incredibly vibrant colors and very durable prints. It's definitely your go-to for simple logos and promotional graphics on smaller runs. Contrast that with flexographic printing. This is all about speed and efficiency. It gives you blazing fast printing speeds and really consistent quality, making it the undisputed champion for massive, high-volume retail orders where keeping costs down is the top priority.
But finishing isn't just about the ink on the bag. Consider embossed Spunbond fabric.
By passing the material through specialized rollers, manufacturers can actually add a textured, premium finish to it. It elevates the whole brand perception. Suddenly, you've taken a standard, flat piece of packaging and transformed it into a luxury, tactile experience for the customer, and you do it while maintaining the exact same structural strength. It's a small detail, but it makes a massive psychological difference.
Section 5. Finding the right supplier.
Okay, so you know the science, the specs, and the finishes. How do you actually source this stuff correctly without making an expensive mistake? Well, here is your ultimate buyer's checklist to use when talking to manufacturers. First, explicitly state the correct GSM for your expected load capacity. Second, optimize your roll width to minimize waste during the bag cutting process. That alone saves a ton of money. Third, decide right away between plain or those premium embossed finishes. Fourth, confirm the material's ink adhesion and print compatibility for your specific graphics. Fifth, always check for batch color consistency and tensile strength. And finally, verify their quality certificates. If you hit every single item on this list, you're going to avoid a lot of wasted expenses and production nightmares.
To put this into a real-world context, the source material points to Najuran as a prime example of a reliable partner in this space. They essentially check all those boxes we just discussed. They're an experienced international supplier offering custom GSM, multiple roll widths to reduce waste, both plain and embossed finishes, and strict quality control along with export-ready packaging. Honestly, working with any supplier that maintains these strict international standards is the only way to guarantee your end product actually performs when it's in the hands of the consumer.
So, as we wrap up today's explainer, I want to leave you with a thought. We've seen the material science, the incredible production efficiency, and the aesthetic potential of polypropylene Spunbond fabric. The tools for creating sustainable, cost-effective packaging are literally right here. The only question left is, how will you optimize your brand's packaging footprint? Thank you so much for learning with me today, and I'll catch you in the next explainer.